Let's solve a problem involving parametric derivatives. We'll find dy slash dx given the parametric equations x equals a cosine theta and y equals a sine theta. To understand this better, let's visualize what these equations represent. These are actually the parametric equations of a circle, any point x, y. On this circle can be represented using these equations, where theta is the angle from the positive x-axis. To find dy slash dx, we'll use the chain rule for parametric equations. The formula states that dy slash dx equals dy slash theta divided by dx slash theta. Let's find dx slash theta first. When we differentiate x equals a cosine theta with respect to theta, we get negative a sine theta. Next, let's find dy slash theta. When we differentiate y equals a sine theta with respect to theta, we get a cosine theta. Now we can substitute these into our chain rule formula. We get a cosine theta over negative a sine theta. The a's cancel out in the numerator and denominator. This gives us negative cosine theta over sine theta, which is the negative of cotangent theta. And there we have it. We've found that dy slash dx equals negative cotangent theta. This tells us the slope of the tangent line at any point on our circle.